The next idea is concentric circles. So write down, if we consider circles with same center but different radii, then they are called concentric circles. Okay. If we consider more than one circles with their centers being same but their radii being different, then they will be marked as concentric circles. If center and radius both are same, then they are not concentric but they are coinciding circles. We cannot visually distinguish two such circles, right? And if we ensure that the standard general equations for concentric circles, they will differ only by the constant term. And why it will happen so? Like if we consider the standard general representation of any circle, the first fourth term is supposed to be x square plus y square plus 2gx plus 2fy, where minus g and minus f are the center. So if centers are same for all the circles, this first fourth term will be identically same for all the circles. Is that okay with everyone?
Yes, sir.
And hence the variation of radius will be only occurring through variation in the constant term. So if we get to standard general equations of concentric circles, then they will be having the difference only in the constant term. If I remove the phrase standard general, will the conclusion still be true? If I just say the equations of two concentric circles will always differ by the constant term only, will that be a right conclusion to follow? Like you can identify two equations, x square plus y square minus 4 is equals to 0. Can you identify the center and radius for this circle?
0, 0 center.
So center is origin and radius 2 units.
Yes, sir.
Okay. I can think of a concentric circle with this equation whose center is origin and radius is 1 unit.
Yes, sir.
Yes, sir.
But are there equations differing in the constant term?
No.
No, sir.
So that's the problem will happen when we will remove the phrase that standard general. The difference only in the constant term, it can be ensured only when we do have the equation being represented standardly. The moment we have written the second equation when multiplied with 4, it is not anymore guaranteed to differ only in the constant term. Even we have got the representation where the constant terms were same, but the variable associated terms has appeared with different coefficients, right? Is that clear? So if we keep our representation restricted to standard general form of circle, we can have this benefit that the equations of concentric circles will differ only in the constant term. Okay. Now on that basis, let us address this example that we are going to find concentric circle of x square plus y square minus 4x minus 6y minus 23 is equals to 0. So even before we proceed ahead, can we identify the circle itself? What is the center and the radius for this given circle?
Two comma 3 is the
Very
center.
good. 2, 3 is the center and radius?
4 plus 9, root over 4 plus 9 plus 23. It is
That
root
is
over 36.
36. Root over 36 means, on a simple note,
6 units, sir.
6 units. So everyone comfortable with this conclusion?
Yes.
That the circle we are dealing with at this moment is definitely having center at 2, 3 point and radius is 6 units. Anyone having any confusion regarding this conclusion?
No, sir.
Okay. So the first part that we need, we are searching for a concentric circle passing through origin. Now drop your pens. We will try to answer this section without usage of pen. Let us have a try whether we can get it without pen or
I
not.
got an answer.
Okay. So as soon as we are searching for a concentric circle passing through origin, do I need a calculation or can we go directly?
You can go directly.
Okay. What will be the equation? Anyone?
X square
X square plus
plus
y
y
square minus
minus
6 is equal to 0.
Sir, the last term will vary.
Only the last term will vary. And we do have the information that the circle is passing through origin. So what will be the constant term now?
The 0.
0.
Zero.
So we know concentric circle. So only the constant term will vary in standard general form. We know passing through origin. So the new constant term will be 0. So we can complete this equation. Do we need any calculation for that?
No, sir.
No, sir.
Is it okay?
Yes, sir.
Now, for the next question, it is we are searching a concentric circle with radius 5 units. Okay. Now I am showing you how we can get it without any calculation that's needed to be written, how verbal calculation can work. Now, what is the present radius of the given reference circle?
Units.
6 units, right? The given reference circle that has radius 6 units. So that means radius square
Yes, sir.
is 36. And for the required circle, radius square is 25.
11 difference.
So radius square is increasing or decreasing?
Decreasing.
Decreasing. By what margin?
11 units.
11. So constant term will be increasing by same margin.
Yes, sir.
Yes, sir.
Okay. So the new equation is going to be x squared plus y squared minus 4x minus 6y minus 23 plus 11 is equals to 0. Right?
Yes, sir.
Or in simple form with the calculation you can make it plus 12 is equals to minus 12 is equals to 0,
Yes, sir.
and this minus 12 is nothing but minus 23 plus 11, right?
Yes, sir.
Is it okay? Out of that, this particular section, this plus 11 is nothing but present radius square minus new radius square. Okay? So that was 11, which was drop in the radius square measurement, and hence that has appeared as rise in the constant measurement or constant value. Okay? So is the procedure clear for all? If we know this procedure, do we need pen and paper for this calculation or can it be done verbally?
Sir, verbally.
It can be done verbally.
So for the next question, you should answer me verbally very quickly. That what is going to be the equation of this circle?
So it's x square plus y square minus 4x minus 6y minus 36. Sorry, yeah, minus 36.
Very good.
Yes, sir,
It's
minus.
only-
This is the equation we have got, right?
Yes, sir.
That is equivalent to x square plus y square minus 4x minus 6y minus 36 is equals to 0. So is it clear to all? So
Yes, sir.
what made us more time efficient is not any theory, but some particular observation. It is r square and c, they varies inversely, but with identical margin. This small observation has made us time efficient here, right? Due to that identification, we can answer this question without pen and paper and very easily and very quickly, right?
Yes, sir.
So all the small observations will play their role. Okay. Now let us have some more example with concentric circles. Okay. Like if we consider that there's this light blue circle having center at alpha comma beta and radius r, and there is a red circular disc rolling over the circumference of this light blue circle. And if the radius of this red circular disc is r1, the center of the rolling circle will describe a concentric circle with new radius r plus r1.
Yes, sir.
Is it okay with everyone?
Yes, sir.
Because throughout the roll, the distance of the rolling center from the circumference will stay r1, as it is a circle rolling. Circle is symmetric in all directions. So even due to roll, the distance from the circumference of light blue circle will never change. And if the distance from the circumference doesn't change, so is the distance from the center of the existing circle does not change. And accordingly, we will have the locus as this greater circle, which is the concentric circle with new radius r plus r1. Okay. Similarly, if this roll been taken place inside, like over here, we are considering this is our reference circle, and the circle of radius r2 is rolling within the circumference. Okay. In that case, the center will always be at a distance r minus r2 from the existing center. The variable center or center of rolling circle will always maintain a fixed distance r minus r2 from the center of the greater circle, and hence the locus will be this circle, which is concentric circle with new radius r minus r2. Is it okay with everyone?
Yes, sir.
Yes, sir.
Now some references that we can get from circular geometry. Locus of the midpoint of chord subtending fixed angle 2 theta 1 at the center of the circle x minus alpha whole square plus y minus beta whole square is equals to r square. Okay, so that means we are thinking of a circle whose center is c alpha comma beta and radius is r. Now, if we think of a chord AB subtending angle 2 theta 1 at the center, the moment we will draw the perpendicular bisector from this center, it will be splitted into two equal halves of theta 1. Is it clear?
Yes,
The
Yes,
total
sir.
angle 2 theta 1 will be splitted. And earlier already we have identified, in that case, the chord of fixed length which subtend a fixed angle also maintains this distance to be fixed, and it is r cos theta 1. We have discussed that earlier.
Yes,
With the property, geometric property. This is r cos theta 1. Even you can identify this is r, the base angle being theta 1. So projection of r will give us the length r cos theta 1, right? And we know that the perpendicular from center also bisect it. So foot of the perpendicular is the midpoint of the chord?
Yes, sir.
Now, if we think of other chords of this length, okay, how to check for that? Okay, let us consider I am rotating this circle. So now I can think of it is the same circle and it is a different chord. But if the subtended angle is 2 theta 1, the distance of the midpoint from the center still r cos theta 1.
Yes, sir.
Okay. And hence we can think of the midpoint will describe a concentric circle with new radius r cos theta 1. Is this description clear with everyone?
Yes, sir. Yes.
Next, locus of the point of intersection of tangents for that circle with center alpha comma beta and radius r, which are inclined at an angle 2 theta 2 in the circle containing part. Okay. So say P is such a point from where we can draw a pair of tangents to this circle with center alpha comma beta and radius r, and the angle subtended was 2 theta 2. We have gone through this idea that the angle bisector will pass through the center.
Yes, sir.
So the angle bisector will divide 2 theta 2 angle into 2 equal halves of theta 2.
Yes, sir.
Okay. Now this theta 2 is a constant given angle, r is constant. So we can identify this distance of P from the center is also a constant. And this is nothing but r by sine theta 2. Or you can also write it as r cosec theta 2. And as soon as you identify that P is maintaining a constant distance from the center of existing circle, you can conclude the locus to be a concentric circle with new radius r cosec theta 2. Is that okay with everyone?
Yes.
Sir, could you explain this one again?
Yeah. Like what we have gone through, firstly drawn the angle bisector for the pair of tangents, and hence we have got the total angle 2 theta 2 been splitted into 2 halves of theta 2.
Yes.
And theta 2 is a given constant angle.
Yes, sir.
If theta 2 is fixed and this radius value is fixed, let us mark the center as C. So CA by CP, which is sine theta 2, that's a fixed value,
Yes, sir.
out of which CA is constant R.
Yes, sir.
So CP has to be constant value R by sine theta 2, or you can mark it as R cosec theta 2. So P, a variable point maintaining fixed distance from the center, and that fixed distance is R cosec theta 2, confirms that locus of P or path of variation for P will be a concentric circle with new radius R cosec theta 2.
Okay, sir.
Is it okay with everyone?
Yes, sir.